Dear students, I welcome you all to this session. Topic of today is hydrides of halogens. Myself, Dr. Digna Varghese. Hydrides of halogens includes its acidic strength, reducing property, and boiling point. Hydrides of halogens. The hydrogen halides are diatomic inorganic compounds with the formula HS, where X is one of the halogens, that is, can be fluorine, chlorine, bromine, iodine, or astatine. All the halogens react with hydrogen to give hydrogen halides. The general formula of hydrogen halide, that is HX, and hydrogen in the gaseous state and halogen is also in the gaseous state reacts to each other to give hydrogen halide. The general formula of hydrogen halide is HX, and if X is fluorine, then hydrogen fluoride is obtained, and if X is chlorine, hydrogen chloride formed, and if X is bromine, hydrogen bromide formed, and X is iodine, that is hydrogen iodide is formed. If X is astatine, hydrogen astatide is formed. Hydrogen halides are gases that dissolve in water to give, which are commonly known as hydrohalic acids. These all hydrogen halides are in the gaseous state, which when dissolved in water to give hydrohalic acids. A halide is formed when a halogen reacts with another less electronegative element to form a binary compound, that is a diatomic inorganic compounds. For example, we have already seen hydrogen reacts with halogens to form halides. The general formula of halides is HX, and the first hydrogen halide is hydrogen fluoride, that can be also known as fluorane, and second one is hydrogen chloride, also known as chlorane, and third one is hydrogen bromide, that is known as bromane, and the fourth one is hydrogen iodide, that is known as iodane, and the last one hydrogen astatide, that is known as astatane. Because of its radioactivity of astatine, these have a limited applications. The hydrogen halogen reactions get gradually less reactive toward the heavier halogens. A fluorine hydrogen reaction is explosive even when it is dark and cold. A chlorine hydrogen reaction is also explosive, but only in the presence of light and heat. A bromine hydrogen reaction is even less explosive than the others. It is explosive only when exposed to flames. Iodine and astatine only partially react with hydrogen, forming equilibria. Hydrogen fluoride, that is also known as fluorane. Hydrogen fluoride is a highly dangerous gas, forming corrosive and penetrating hydrofluoric acid upon contact with moisture. This photo shows the corrosive nature of hydrogen fluoride. The gas can also cause blindness by rapid destruction of the corneas. The gas is highly dangerous. In 1707, Carl Wilhelm Scheele prepared the aqueous solution of hydrogen fluoride. Carl Wilhelm Scheele was an Swedish and German pharmaceutical chemist. French chemist Edmond Fremy is credited with the discovering anhydrous hydrogen fluoride while trying to isolate fluorine. Edmond Fremy was a French chemist. He also credited with the discovery of anhydrous hydrogen fluoride while his experiments to isolate fluorine. He conducted experiments to isolate fluorine. And other methods of preparation of hydrogen fluoride is by the action of high sulfuric acid on fluoride, that is calcium fluoride, giving hydrogen fluoride as the product. 20% of the hydrogen fluoride is obtained by the byproduct of fertilizer industry, that is when it is treated with the fluorosilicic acid, hexafluorosilicic acid, giving hydrogen fluoride and silicon tetrafluoride. Silicon tetrafluoride undergoes hydrolysis, giving hydrogen fluoride. Hydrogen chloride. It is also known as chlorine. It is an important chemical reagent and it is an important industrial chemical. It has a distinctive pungent smell. It is highly corrosive on contact with water found in body tissue. It is in aqueous solution forms hydrochloric acid, which is strongly acidic. That is a good lab reagent. It is a naturally occurring component of the gastric acid produced in the digestive systems. When it is diluted with water, forms diluted hydrochloric acid, that is often used as a descaling agent. What is a descaling agent? Descaling agent or chemical descaler is a chemical substance used to remove lime scale from the metal surfaces in contact with hot water, such as in boilers, water heaters and kettles. Limescale means is a hard, chalky deposit consisting mainly of calcium carbonate that often builds up inside the kettles, hot water boilers and pipework, especially that for hot water. It is the limescale deposition that can be removed by dilute hydrochloric acid. So it is used as a descaling agent. Inhalation of the fumes can cause coughing, choking, inflammation of the nose, throat and upper respiratory tract, and in severe cases pulmonary edema, that means excessive fluid in the lungs, circulatory system failure, and finally can cause death. Skin contact can cause redness, pain and severe skin burns. Hydrogen chloride may cause severe burns to the eye and permanent eye damage. Discovery of chlorine. Hydrochloric acid was discovered by the alchemist Jabir bin Hayyan around the year 800 AD. Jabir bin Hayyan was known as father of Arab chemistry. During that time, HCl was historically called acidum salis or spirit of salts, and in the gaseous form of this wave, gaseous form known as marine acid air. In the 17th century, Johann Rudolf Glauber used salt and sulfuric acid for the preparation of sodium sulfate, that is Glauber's salt, releasing hydrogen chloride gas. Johann Rudolf Glauber was also an alchemist, and in 1772 Carl Wilhelm Scheele also reported this reaction and is sometimes credited with its discovery. In the same time, Joseph Priestley prepared hydrogen chloride in 1772. Joseph Priestley is best known for discovery of oxygen. In 1810, Humphrey Davy established that it is composed of hydrogen and chlorine. Synthesis of hydrogen chloride. First method is direct synthesis. direct synthesis of hydrogen chloride by the use of brine solution. The brine solution is a mixture of sodium chloride and water. When it undergo electrolysis, getting pure chlorine gas and sodium hydroxide and hydrogen gas. When this pure chlorine gas undergo direct combination with hydrogen in the presence of UV light giving hydrogen chloride gas. By the direct combination of chlorine and hydrogen giving in the presence of UV light giving hydrogen chloride gas. Second method is laboratory synthesis. In the laboratory synthesis of hydrogen chloride, we are using a hydrogen chloride generator. In this, sodium chloride treated with sulfuric acid giving sodium bisulfate and hydrogen chloride. This reaction occurs at room temperature. When the temperature is increased up to 200 degrees Celsius, the second step starts. Sodium chloride remains in the generator, that is reacted with sodium bisulfate at 200 degrees Celsius giving hydrogen chloride gas and sodium sulfate. Sodium sulfate is known as Glauber's salt. And other method used for the preparation of HCl in the lab is when treated with phosphorus pentachloride with water giving phosphorus chloride, that is also known as phosphorus oxychloride and hydrogen chloride. Hydrogen bromide, that is also known as bromine. In pure form, it is a colorless gas. Hydrogen bromide is very soluble in water and forming hydrobromic acid. Both the anhydrous and aqueous solutions of HBr are common reagents in the preparation of bromide compounds. HBr has been proposed for use in a utility scale flow type battery. In this type battery, both the cathode and anode is separated by an iron membrane, and it is like a fuel cell or an electrochemical cell. HBr is highly corrosive and irritating to inhalation. Hydrogen bromide is produced by combining hydrogen and bromine at temperatures between 200 and 400 degrees Celsius. The reaction is typically catalyzed by platinum or asbestos. The lab synthesis or laboratory synthesis of hydrogen bromide is by the action of potassium bromide on sulfuric acid giving potassium bisulfate and hydrogen bromide. In this reaction, concentrated sulfuric acid is not used because hydrogen bromide, by the action of concentrated sulfuric acid, it can be decomposed into hydrogen and bromine. The bromine second reaction is bromine reacts with water and sulfur to form hydrogen bromide and sulfur dioxide. Bromine on react with the tetraline giving hydrogen bromide, and bromine reacts with the phosphorus acid and water giving phosphoric acid and hydrogen bromide. Hydrogen iodide, also known as iodane. Hydrogen iodide is a colorless gas. It is exceptionally soluble in water giving hydroiodic acid, and it acts as a strong acid. Hydrogen iodide is used in organic and inorganic synthesis as one of the primary sources of iodine and acts as a reducing agent. Commercial concentrated hydroiodic acid usually contain 48 to 57% hydrogen iodide by mass. Synthesis of iodine, that is when it is treated with hydrazine giving hydrogen iodide and nitrogen. iodine treated with hydrazine giving hydrogen iodide and nitrogen. Second reaction is hydrogen sulfide reacts with iodine, that is, a stream of hydrogen sulfide is passed over to the aqueous solution of iodine giving hydrogen iodide. In this, if water contains the product, to get pure hydrogen iodide, we are simply distilling the mixture and we get pure hydrogen iodide. And third reaction is the direct combination of hydrogen and iodine giving hydrogen iodide. Hydrogen acetate, which is also known as astatine hydride or astatane or acidohydrogen. It can dissolve in water to form hydroacetic acid. It is limited in use due to its ready decomposition into elemental hydrogen and astatine, that is, hydrogen acetate giving decompose into hydrogen and astatine. So it has a limited use because it is an unstable compound, as well as the short half-life of the various isotopes of astatine. We know astatine is a radioactive halogen, so its short half-life, also one reason for the limited use of hydrogen acetate. And second reason is the ready decomposition of formed hydrogen acetate into hydrogen and astatine gas.